Hi, I'm Rachael McKinney, and I'll be presenting the research done by myself and Dr. Jacob Dunbar on comparisons of Ketoprofen Release from Semisolids using the Phoenix DB6 diffusion tester versus the immersion cells. So in vitro release testing, or IVRT, is a way to monitor drug release and diffusion from semi-solid dosage forms. The technique involves measurements of release and diffusion of drug from the formulation through a permeable membrane and into an appropriate receiver medium. IVRT is commonly used in drug development and research, like formulation development, batch comparisons, product development, as a manufacturing quality monitor, and to support scale-up and post-approval changes. While in vitro release testing may not reflect in vivo drug delivery, it can detect release rate differences between formulations, allowing us to predict in vivo performances. Many attempts to validate an IVRT method have been published, but none have been made the cornerstone of testing regarding temperature, volume of receptor medium, stirring speed, membrane compatibility to ensure reproducibility and reliable results. The specific aims of my study were to perform a characterization of the apparatus to ensure equality between machines and determine the components most necessary to show highest drug release. This involves things like stir speed, receptor medium, membrane, and formulation. USP General Chapter 1724 describes several approaches to IVRT, including the vertical diffusion cell, or the Franz cell, immersion cells, and modified USP Apparatus 4, which is a flow-through cell. In our research, we compared immersion cells to the newer Phoenix DB6 diffusion tester for IVRT of Ketoprofen Release from 5%, 10%, and 20% formulations of pluronic lecithin organogel and lipoderm-based cream to find potential for reliability and ease of use. Both apparatuses are comparable in most areas except the receiver volume, which is important for our study's results. For our methods, our study design involved 6 diffusion cells total for each test, 3 of which were lipoderm and 3 were PLO, pluronic lecithin organogel. This test was repeated for each formulation strength. Formulations were loaded into the sample compartments of immersion cells and DB6 cell caps, 3 per formulation and per strength. A 0.45 micrometer supporter membrane provided the interface between sample and receiver media. The assembled immersion cells were placed in flat-bottom vessels, a USP2 apparatus, containing 100 milliliter phosphate buffered saline, PBS, at a pH of 7.4 at 32 degrees Celsius and paddle speed of 100 RPMs. Temperature of the receptor media was maintained at 32 degrees Celsius throughout the experiments to reflect normal skin temperature when a semi-solid dosage form is applied to the skin. This is a consistent temperature used for most articles discussing IVRT of topical semisolids. Assembled DB6 cell caps were placed on the diffusion cells containing 30 milliliters of PBS at 32 degrees Celsius, magnetically stirred at 200 RPMs. Per the Hansen Research Diffusion Method Guidelines, 100 RPMs is sufficient for immersion cells. Extremely high rate may change the membrane and receptor media interface, and an extremely slow stir rate may not allow homogeneous mixing of API and receptor media. So a stir speed of 200 RPMs was selected for DB6 to closely match the immersion cell stir speed. 200 RPMs was the lowest number possible. Samples of 1 milliliter from the immersion cell and 500 microliters from the DB6 were collected at 0.5, 1, 2, 3, 4, 5, and 6 hours after the application of the ketoprofen, and were replaced with 1 milliliter or 500 microliters of receptor medium respectively. Ketoprofen concentrations were determined by HPLC systems using modifications of the USP methods for ketoprofen tablets. We used a C18 column, a mobile phase made of acetonitrile, acetic acid, and water with a ratio of 90 to 1 to 110, a flow rate of 2 milliliters per minute, and a UV detection at 250 nanometers. So comparisons of the DB6 results and immersion cell results show graph data is very similar in release profiles as seen in figures 1 and 2. Data from both apparatuses show that cumulative ketoprofen diffusion from both formulations expectedly increased with drug concentrations. However, in the DB6, flux from the 20% did not exceed that from the 10% formulation visible in figure 2. Lack of difference between the 20% and 10% in phosphate buffered saline, or PBS, is likely due to compromised sink conditions of the lower volume in the DB6 cell. In order to address the lack of change between 20% and 10% in the DB6 apparatus, we adjusted the receptor medium. Our adjusted receptor medium comprised of 40% ethanol, which was 120 milliliters of PBS and 80 milliliters of ethanol. The experiment was repeated using the same methods. Our results from the new receptor medium are seen in figures 3 and 4. Ketoprofen drug release from PLO and lipoderm into the 40% ethanol receiver medium showed improved diffusion as compared to the PBS. The differences in release rate between 10% and 20% formulations using an ethanolic solution allowed for higher ketoprofen solubility to overcome the suspected inadequate sink conditions. Both formulations in 40% ethanol now show slopes proportional to API concentration. What is consistent with this and our previous IVRT studies, regardless of receptor medium, PLO still has greater drug release than lipoderm. This is interesting considering PCCA has demonstrated skin permeability of ketoprofen as higher from the lipoderm versus the PLO, although in vitro release testing and in vitro permeability testing are tests of two different processes. In conclusion, using appropriate receptor medium, both the immersion cell and the Phoenix DB6 apparatus demonstrated in vitro release testing results that are comparable and have reliable release profiles. Both apparatuses allowed the conclusion that PLO formulations have higher diffusion than lipoderm at all concentrations with a release rate proportional to API concentration. Based upon simplicity, reliability, and ease of use, the Phoenix DB6 diffusion tester should be considered an IVRT system of choice.